All right, good evening, everybody, and thank you for joining us. This is the second in a series of 4 grade-specific webinars that we've been running. We had K2 and 3-5 the last couple of weeks. Tonight, obviously, is 6-8, and next week is 9-12. And if you're interested in the recordings of those that we've already run, or next week's, those recording links will be available to you. The webinars are all organized around a collection of resources that are entitled Bringing the Universe to America's Classrooms. That's the name of the collection. And it's a project between GBH, a collaboration with GBH and NASA. The collection is available free on PBS Learning Media, which is a site I'm sure many of you are already familiar with. And we're going to talk about the collection and then get involved with a teacher also a little bit later. I'm Carolyn Jacobs. I'm Senior Manager of Training and Educator Engagement in GBH Education. We are using a Zoom webinar as our platform. Only the presenters are on camera and the presenters have the mic. We're recording and we'll send out the recording link tomorrow in a follow-up email. We have Angelica in the chat from GBH Education, and she'll be posting lots of links to, as they are referenced in the webinar. And there'll also be a link to a survey later on and also a resource document. So all of that, everything you can possibly need, I hope we're able to give you. At the end, the survey link that you can go to will also, if you complete the survey, it's very brief and we really appreciate getting your feedback. You can download a certificate that acknowledges that you participated in this session. The session is sponsored by GBH Education, which is a department of GBH, Boston's public media station, and the producer of many of the programs that you see on your station wherever you are. NOVA being an example, American Experience, Frontline, Masterpiece, etc., and lots of programs for kids. And we're also sponsored this evening by PBS Learning Media. Whoops, I jumped a slide here. PBS Learning Media is a free website offering thousands of digital resources for K-12 and across the curriculum. It is very strong in science. And again, this is the website where you will find all of the resources you're going to see tonight and the collection Bringing the Universe to America's Classrooms. Our main presenter this evening is Shawn Stevens. She is Director of STEM Curriculum and Instruction here at GBH Education. And she is joined by Nancy Gifford, Monomoy Middle School in Chatham, Massachusetts on the Cape. Nancy teaches middle school, and she is a long time collaborator with GBH Education. I think we determined that she and I met maybe 8 or 9 years ago. I've lost track now. She has advised us on numerous projects, Bringing the Universe to America's Classrooms being one of them, and she's presented at many conferences and webinars for us, and we really value her input. Nancy was also the Massachusetts Science Teacher of the Year a couple of years ago. So Shawn is going to kick things off and give us a quick overview of what the collection is all about, and then dig into some specific examples. And then we'll hear from Nancy, a teacher's perspective, showing us how she uses the collection with some very specific strategies and how she works them into her lessons. And then I'll come back on for a couple of minutes at the end with some closing remarks. All right, I'm going to turn it over to Shawn.
Hey, thanks, Carolyn. As Carolyn mentioned, I'm going to talk about a particular collection in PBS Learning Media that's related to the project, Bringing the Universe to America's Classrooms. And this project is a collaboration with NASA and their affiliated organizations, as well as teacher advisors from across the country. And Nancy, who you'll be hearing from later, is one of those teachers. And they've given us so much valuable feedback that will hopefully make these resources useful to you. The resources in this collection focus on key concepts within Earth, space, and physical science for K-12 students. They're not actually curriculum materials or full-blown units or anything like that, but they're supplementary resources. So they're meant to fit into your curriculum and give a little extra support whenever your students need it. So to that end, they're really flexible and adaptable, so you can use them in a lot of different ways. Next slide, please. This here is the our homepage for the collection. And you can see that the resources are organized by grade band. And within each grade band, there are sub-collections arranged by topic. For 6-8, you have all of those same collections: wave, space, earth systems, and weather and climate, as well as story of Earth. And then within these topic collections, there are a number of resources that target NGSS disciplinary core ideas and help engage students in science practices. Next slide, please. The types of resources that we have are lesson plans, which are just typical learning experiences arranged around a learning goal. We have interactive lessons, which are kind of souped up slideshows, so students can interact with media. There's associated text and learning activities all associated, and students can just work through them independently at their own pace. Teachers have found these really, really useful, especially at this time of hybrid and remote learning. In addition to those, we have videos, images, models, simulations, games, and other types of visualizations, all to help students engage in phenomena and science practices. Next slide, please. So even though I said that they're supplementary resources, they come with some stuff. So first of all, this is a NASA project, so it's 508 compliant. So we have a lot of accessibility features. The student handouts and interactive lessons are all screen reader compatible. All the images have descriptions, all the videos are closed captioned, and a lot of the videos also have descriptive video. Let's see, so we're also in the process of translating our all the student-facing resources into Spanish. If you look up at that little yellow badge up there that says also NES, that indicates that it's been translated into Spanish. And that's not just for this collection, but throughout PBS Learning Media, if you see that. There are also support materials for teachers, some background for content, as well as the media itself, and ideas about how to use it and teaching tips, and some ideas for discussion questions as well. In addition, a lot of the resources come with handouts directed to students. One thing I don't want to forget is that you can assign these resources through PBS Learning Media, but also through Google Classroom, Canvas, Seesaw, Schoology. They're always adding new ones. So if you have a question about the software that you use, just go to the help page and check it out. Next slide, please. Okay, so this is, you know, when we think about digital media and using that in the classroom, so often it's a passive experience where somebody's just explaining something about a phenomenon to students. And that's really not what we wanted these resources to be. We wanted to make phenomena accessible that aren't necessarily accessible, let kids see phenomena in multiple perspectives, and just really provide opportunities for students to actively engage with the media. We want them to observe, make observations about phenomena, look for evidence to support claims, and collect and analyze their own data. Next slide, please. So really what it comes down to is we want to provide opportunities for students to figure stuff out. We don't want to be telling them stuff. Next slide, please. So as I mentioned earlier, these are the topic collections. These 5 topic collections are available for at the middle school level. Right now we have about, I think 200, we have about 200 in the whole collection, and about 140 resources directly from using NASA resources. Tonight, though, I'm going to talk primarily about those first 4, or resources from those first 4 categories. And these are all new, so if you've been here before, you won't have heard about these. Next slide, please. Okay, so we'll start out with WAVES. We have we made a set of interactives for students to help them conceptualize the relationships amongst the characteristics of waves. So the relationships between wavelength, amplitude, frequency, and energy. You can see here, this is just an interface of the frequency one. It's illustrated through the waveform, sound, and light. So for the sound ones, they would be able to hear. Next slide, please. Here's the example for frequency. You can see the slider at the bottom. They can, and this is for light, they could adjust the frequency, and it's manifested in different colors of light. In parallel, there's a change in the waveform and the wavelength. This isn't exactly to scale, but it's just to conceptualize that there is a change. But if you notice over on the right, while when the frequency changes, the wavelength changes, the amplitude doesn't necessarily have to change. So this is just to help students conceptualize these relationships. Next slide, please. And this one is for amplitude, also light. And there's a slider on the right there that allows students to adjust the amplitude. And in this case, it's going to be the brightness. And the waveform adjusts in parallel. And can also see that even though the amplitude is changing, the wavelength and frequency don't necessarily change, but the energy does. Next slide, please. Okay, so this is another interactive that we made so students can just have a little more free-form modeling of waves. Can you please play, Carolyn? So this is a lot like the ubiquitous Slinky activity that we have. So students can see transverse waves, can model longitudinal waves, and then they can also do their own thing. So it really is a lot like the Slinky activity. And I think this would be useful if you actually do the Slinky activity afterwards when you're doing the sense making discussion, to have this projected and help illustrate and help students communicate ideas. Students can use this while they're answering their questions after doing the activity, or even now in this remote learning situation, it could maybe substitute for that Slinky activity. Next slide, please. Another resource we have related to light and waves is this collection of videos related to the reflection of light. There's a video that relates, that provides evidence that light travels in straight lines, the behavior as it reflects off the mirror. You can see here on the left, there's the beams, and that also evidence that the angle of incidence and reflection are equal. In addition, there are videos showing both the phenomena and models for comparing the reflection between a smooth and rough surface. These videos are made so that students can make observations, and there are questions posed within the video. So we try not to make a lot of explanations, so those students can make their own observations, make their own sense of the phenomena. Next slide, please. I think this is our last Waves in Light one. And this is a resource that focuses on the primary colors of light. We have a video demonstration of color mixing of light that you can see that it will be in video form. And then on the right is an illustration of an interactive where students can play with the different colors of light and mix them themselves. In addition, they could choose an image and adjust the amount of red, green, and blue light to get a feel for how color and light mix to make the pictures they see on digital screens. Next slide, please. Okay, finally, we're in this a new topic. This one is can be found in the Earth Systems collection, and it's one of a couple resources we are developing on the water cycle this year. This particular one is a little different because, usually when you see the water cycle, it's that water evaporating out of the water body, makes clouds, precipitates down, always on mountains for some reason, then runs down back into the body of water. This gives a global view of the water cycle using just stunning visualizations from NASA. And these are, it's a series of 4 videos. And not only does it give this global different kind of view of the water cycle, it also can help students start connecting how the energy of the sun is involved and gravity are involved in the water cycle, which is a really important step in the conceptualization. Next slide, please. Another Earth Systems resource that we're excited about is this one is on the cycling of carbon. So this is a new tool that's allowing us to layer complex data on, and it's not quite ready, but hopefully within a few weeks it'll be out. This one is the on the carbon cycle, and it covers both the organic portion of it, which is the typical part with fossil fuels and plant photosynthesis, respiration, and so forth, but also the inorganic, which sometimes we forget about. Next slide, please. The way this will work is that can pick a layer, there'll be hot spots, and you can see the information about which process in the cycle the hotspot is related to. They can choose which layer they want to look at or and which combinations. Next slide, please. And then finally, if we pick a hotspot, then can see image or video and or text about each of the processes. So we have a resource for this, obviously about the carbon cycle, but we have one in development also for water cycle and the electromagnetic spectrum. So if any of those interest you, check back in a month or so. Next slide, please. This is another kind of cool resource that was developed in collaboration with Worldwide Telescope ambassadors at Harvard and NASA's Universe of Learning. And this is a really cool tool that lets students actually interact with real data about the solar system and explore properties. Carolyn, would you please play the video? So you can see on the left, those are all the objects that are available for exploration. When you click on one, you'll zoom in and get to go there eventually. So I picked Mars since Mars is in the news. Students can rotate. They can see day and night. You can turn off that realistic lighting so that you can see the whole surface, zoom in more or less. The cool thing about this being real data is that if I stopped rotating it, it's actually moving and it's actually rotating. So you can control and speed up the time scale so that you can compare how fast or how long a day is on each of these bodies, and the distances to scale. The default of the actual sizes is 25 times bigger, just so you can see that they're there. But so yeah, because it's real data, all this stuff is real and to scale. So we're really excited about this tool too. Next slide, please. Okay, and finally, this is another coming soon. And this is a virtual field trip to around North America, where students can just visit various landforms. They can zoom in on any point in the image. These are super, super high resolution images, like hundreds of them stitched together to make these beautiful panoramas. Up on the left, there's an orientation screen that lets you know where you are in the image as you zoom in. Next slide, please. So just as an example, I'm zooming in and you can see that I'm not even zoomed in all the way. This is like 2/3 in, and I'm already close enough that I can see what type of rocks there are. I can see evidence of biological weathering, because there's all these plants growing in the cracks. Up there on the left, that little yellow square, that's where I am in the picture. So I can use that square and drag that around to go to different places in the image, or just, you know, track it if I want to sketch or indicate where I found evidence, in this case, maybe of erosion or weathering. Next slide, please. So here, if I just move down and back into time, can see in this case, there's a different type of rock, and everything. So we're close enough that we can actually make these observations of these landforms. And so students can often zoom in and almost see like individual. So I think that's it for me. And I hope I've inspired you to at least explore our collection and maybe try some of this new media out. And now I'm going to turn it over to Nancy, who will tell you more in depth how she uses some of our resources.
Hi, everybody. I am so happy to be here and excited to share with you some of the resources. I was given free rein to pick out what I wanted to choose to show you tonight. So I decided that I would focus on two concepts that I find really challenging to teach to my students. And this year, we know, has been the hardest year of our teaching careers. No matter how long we've been at this, it's been rough. And one of the things that I've been really limited in is how many hands-on activities I can do with my students. And that's been frustrating for me. Sean said earlier that we don't want this to be a passive experience. And so the resources that are in the PBS Learning Media website, and in particular, the Bringing the Universe to America's Classrooms, are really great for teaching the practices. And the more you explore the different resources, the more you're going to see how many of these practices you can actually teach using the different resources. And one thing I did want to mention about the interactive lessons, if you haven't explored those and tried those with your students, they're fantastic for sub plans, and they're really great if you are teaching asynchronously or synchronously, depending on how you're doing it with if you're doing remote learning or you're in the classroom. If you're in a hybrid model, you can really work with all the kids at the same time. And it's just been great for me. So I just put this up here to remind you of the practices. And what we're going to do is we're going to see how many of these we can hit over the next few lessons. And I'd like to argue that we'll get to all 8 in just 2 lessons. So Carolyn, could you go to the next slide, please? So this is all about understanding the phases of the moon, which I have not been able to figure out why it's so challenging for middle schoolers to understand moon phases. But I think it's challenging for adults too sometimes. And so what they've done is they've put together a 2-part series of interactive lessons that help kids explore and understand the phases of the moon. So this won't replace your ping pong ball model of the moon and what you're doing with the kids in the classroom, but it's a great addition to what you're already doing. So if you could advance the slide, Carolyn. And then if you want to go ahead and put it in motion, that would be great. So this is a fantastic resource. What this does, this is the first step. There's 2 different levels of this. This is the more basic version. And if you take a look, you can see that it's showing you how the Earth is rotating. You can see the orbit of the moon. And what I love is that you can see very clearly on this, if you're looking at just the moon in that little model, that half of that moon is always lit up. And that will help get rid of that idea that there's a dark side of the moon, except of course for the Pink Floyd album, which, we love, but half that moon's going to stay lit all the time. And at the top, you can see they're showing you how the moon would look from Earth if you were standing near one of those houses. And then you've got your little person on the orbiting Earth below who can, passing in and out of day and night. And then if you want to, Carolyn, you can show how you can, this is just running on its own, but the student can also control the position of the moon by clicking on it and dragging it. And they can also, I think you have to hit pause first. Yeah. So Carolyn can put the moon where she wants it to see which moon phase, where the moon is. So if you're used to showing moon phases and it takes a whole month to have the kids observe the moon, or if you live like where I do, where it's cloudy every time there's anything interesting going on in the night sky, this can speed up that process for you. So the kids can see how many days it's been since the moon. They see the moon phases. They can click ahead by an hour or a day. So it's just a great resource for modeling this sun, moon, Earth system. And then the next slide, when you're ready, Carolyn, will show us the more advanced version. So this would be after your kids have worked their way through part 1. I wouldn't recommend skipping ahead to part 2 unless you're teaching high school or something, because I think the part 1 really helps build that understanding. This has a more advanced view of our version is a more advanced version. And go ahead and hit play. And we can watch the new moon. It tells you what percentage of the moon is illuminated with the phases. And I think that helps the kids see that it's a gradual process, and it's helps drive home the point that, yeah, it's only a portion of it that's illuminated and visual, and the rest of it is just in the shadows, and that it's still there. We just don't see it. And I think kids don't always understand that. There's also under the little pause button, there's a way to put in the time tick marks. You can click that, Carolyn. And now they can see the sunrise, sunset, and midnight, and another way you can use it in your teaching. So yeah, so that's a great thing to play with. When you have the time, you'll probably get lost. Well, like I do when I start looking at these interactive lessons, I go down a rabbit hole and I spend hours looking at every resource. But Okay, Carolyn, if you want to go to the next slide, that would be great. So here's an example of one of the teacher handouts that's available for you, where the kids can make their observations, record their data, and keep track of what they've been looking at. I would probably have them play around first before I'd even attempt to give them this, and maybe do a few practices with the class before I let them loose. Next slide, please. And then within the interactive lesson, there are quizzes. These are self-graded quizzes, which is great in this busy time where we're all scrambling all the time, it seems, to keep things running smoothly with our kids. But this gives them immediate feedback for all the quizzes. And if you notice up at the top under the phases of the moon heading, it's a little toggle switch. So it is available in English or Spanish, which is great. Next slide. And then here's a sample of the answer key. I didn't know where to find the answer key, and then Sean told me to find it. It was in the teacher supports. Then I found it very quickly, and I was relieved to see it because I was starting to doubt myself after I played around with it for a little while. So I think it can be very reassuring to have those answer keys, especially when you're busy. And then, just like all of the other resources on the PBS Learning Media website, this lesson has a list of other resources you might want to go to. So there's other videos, there's simulations and other activities that you can use with your kids for further understanding, for review, for challenge, whatever you might need with your kids. So you can really customize it for your students. Next slide. Okay, here's another of my favorites. I am teaching earth science right now, and I was hoping to do this lesson with my students before I did this presentation tonight, but time just wasn't working well with us. This is from a series called Making North America. It's actually a 3-part NOVA series. Each episode is about 45 minutes long. And my students love this movie. They begged me to let them watch all 3 episodes back to back to back. So they really enjoy it. The star of the show is Kirk Johnson, and he is a paleontologist who is just fantastic at making earth science exciting and accessible for everyone. And what he does is he will travel around, and he'll be going across North America, and he's trying to understand the geology of North America and looking for evidence to answer his question. So if you can go to the next slide, Carolyn. So what's great about this is, in these days where we're not able to do a lot of hands-on activities, it's harder for students to take that role of a scientist and actually be doing some of those hands-on things. So this is a great way for students to observe a scientist doing the work of a scientist, asking questions. And I use this clip for writing claim evidence and reasoning statements with my students. And so in this clip that you're about to see, Kirk is attempting to answer the big question: is the West Coast due for a major earthquake? And so what he does is he's going out with this geologist named Brian Atwater, and they're off Washington State, and they're looking for evidence in the a marshy area that will be their beginning of their adventure to find out whether or not they think the West Coast is due for a major earthquake. So if you want to hit play, Carolyn, that'd be great.
Slicing into the bank reveals 3 layers. They tell a story of change over time. The lowest once supported a healthy rainforest.
So this is almost like a garden soil, right? But it's got tree roots in it. It's a forest floor soil.
Just above is a layer of sand, entirely out of place. Its sharp definition tells Atwater that whatever put it here came fast and furious.
You don't see sign of a gradual change from here because there's such a black and white difference between this and this. How do we do this combination? How do we go from forest floor to some kind of muddy flat and have a sand layer brought in first, right at that time?
Okay, so that's just a little teaser for you. The whole clip is about, I believe, about 7 or 8 minutes long. from start to finish. And what I do is I have my students watch the clip several times through. And then we start to brainstorm that list of evidence that we're pulling out. If your students are more advanced and have more practice with writing CERs, you could have them work on their own. But my students really need that modeling still. I have 7th graders and some of them are struggling. They're either English learners or they're lower level, and they really need support in identifying that relevant evidence. So go ahead to the next page. In the folder that you'll have access to, I sent you a copy of a write-up that you can use with your students. You can print it out and use it with your students as they're viewing the video and some of the evidence that they'll find. So you'll have that access to that, but you won't see that document tonight. It's just in the folder. But here's some of the evidence that they are going to be showing in this video. They take a look at the Cascadian subduction zone. There's a beautiful animation that shows how subduction works. I was teaching that today, and this animation really helps. And then there's video of it's an animation of an earthquake triggered tsunami that was what really affected the place where Kirk and Brian were just showing, and that's tsunami is what caused the sand layer. So sorry, I gave it away, but now you know. So on the next slide, so another practice that is really important is using modeling. And I think this is all from the same clip, and it's still Kirk Johnson, but he goes to see a different geologist. And what they're doing is they're looking at technology and they're trying to model tsunamis, and they want to see if they can predict past and future events or tsunamis, and then that will link back to the earthquakes. So if you want to go ahead and hit play, we'll see how they are modeling tsunamis in the laboratory, and they're also taking a look at core sediment samples. So go ahead, Carolyn. Thank you.
15 seconds. Tsunami is running.
At Oregon State University, Chris Goldfinger studies deep-sea earthquakes that can cause devastating tsunamis. He's examined hundreds of sediment cores from the seafloor, sampled all along the 700-mile Cascadia subduction zone. Analyzing each one, he's assembled a history of earthquakes going back 10,000 years. And the news is not good. Chris estimates that severe earthquakes strike somewhere along the fault line about every 240 years, most often in Oregon and Northern California.
Okay, so I promise you, if you were to watch the whole clip that's available in the Bringing the Universe to America's Classroom collection, you'll see the whole story start to finish. And that's what I love about these videos, is that they really do a nice job of telling the story and how the scientists are working to build their understanding and answer these questions. So I also think that modeling is really important for career connection. So the kids can see that not every scientist is in a lab somewhere wearing a lab coat. Some of them are out getting dirty, like Brian Atwater, and others are engineers that are building these models, and they're so important for keeping people safe and understanding what's going on with our planet. So the next slide, please. So to put it all together, once the students have watched this video a few times through and they've pulled out their evidence, they should be able to come up with a claim that would, be a restating of that question: is the West Coast due for a major earthquake? And spoiler alert, according to Kirk Johnson and Brian Atwater, yes, it is due for another one. They get them about every 275 years, I believe it was, and they're a little overdue. So the students can put together the evidence from the video and explain their reasoning. And if you want to go to the next slide. Pretty much any standard you're teaching can be turned into a CER. And this is something that I researched with a friend of mine a while back. And I'm not exactly sure where she got this information about the evidence, but the word evidence appears 252 times in the K-12 standards. So if you take your standard and you flip it around, you can make it into a question that students would need to answer. And then that can become the driving question for your investigation with your students. And next slide, please. And one of the things that I struggle with my 7th graders is they want to tell me things like, I think that, when they're writing a hypothesis, or they want to say things like, I was right, or my hypothesis was wrong. And so I spend a lot of time thinking about how to get rid of that language, how to teach them to speak in the third person and to sound more scientific, more professional. And so for my 7th graders, I provide them with sentence starters that live in their notebook, so they can go back to these and use them whenever they need them. And it gives them some ideas for how to get started. And I find them using these statements a lot. And I provided this in the folder for you as well. So you'll have access to this to use with your students. So that should be helpful. And I think that's it for me. If you think about the standards, I think we can argue pretty effectively. We were asking questions and defining the problem. We saw the model of the tsunami. Kirk went out and investigated. We investigated the lunar phases. We can interpret our data, and using math, there was definitely a lot of geometry involved in those lunar phases. We were able to explain a bit about what we saw. And of course, that was just a gloss over of it. And now we're ready to write our CER at the end, so we can communicate our information and argue with evidence. So all the practices just through a couple of resources in this awesome collection. So I'm happy to answer any questions anybody might have for me if you want to type them in the chat, but I'm going to hand it over to Carolyn so she can wrap it up, and we will end right on time.
Yes, we will. Thank you very, very much. Very well thought out and delivered presentations. And yes, we're right on schedule. So as Nancy mentioned, she has generously shared a lot of what she has created here in a folder. And the link to that is part of the resource document that Angelica, I'm sure, has put in the chat, but you will also get a link to that in the follow-up email that comes out tomorrow. So just a quick reminder, in case you haven't heard it often enough tonight, pbslearningmedia.org. That's your go-to website, and that's where you will find Bringing the Universe to America's Classrooms collection, along with thousands of other resources. Lots of resources drawn from NOVA programs. So these are just some banners of other collections on the site, just to kind of whet your appetite. And North America is a collection that was originally the work that Nancy showed, and now it's part of Bringing the Universe. Blood Sugar Rising, that was a webinar and a lesson plan that is on PBS Learning Media that we recently ran, all about the diabetes epidemic, a lesson plan for middle schoolers, and also lesson plan and resources drawn from the program, The Molecule That Made Us. The recordings of the other webinars, we know that many of you teach multiple grades, and so we do have recordings of the K2 and 3-5 webinars available. All of our webinars are recorded and are posted on the GBH Education YouTube channel. 9-12, grades 9-12 is next week. And then coming up in March 23rd and March 25th, a Tuesday and Thursday, are 2 webinars, one for K5 and one for 6-12, all on supporting EL students with the Bringing the Universe resources. So look for information about that coming out very soon. This is the link for the survey. After you complete the very brief survey, you'll be able to download a certificate if you'd like to acknowledge that you participated this evening. Our research people department put the survey together, and we get reports, and we really strive to do better based on your feedback. So please take the survey and be candid with us. Thank you. We're very active on social media, and we invite you to join us there. We post announcements about things, but we also send out email. And if you're not already, by virtue of being in the webinar tonight, you will be on our email list. I want to thank Nancy and Sean and all of you who came. I know that it's a stretch to do things on weekday evenings, on school nights, and particularly in this climate that we're in right now. And we really appreciate your attention and your thoughtful participation. You are welcome to email me with any questions or comments, and I will keep the chat open for another couple of minutes. I also want to thank Angelica, who I'm sure has been very active in the chat, posting links. And we wish you a lovely evening, and thank you again for joining us.